Hello everyone, welcome back. In this video, we will look into arrays in MATLAB. We will start with some basic concept about arrays, and then we will see how to initialize, manipulate, and use them. And at the end, we'll try to differentiate between character and string data types in MATLAB in the context of array. Now, arrays are defined as collection of items. These items can be numbers, text, or any other type of data. To explain the concept of array, I will use an analogy of a grocery shelf. So let's say we have a shelf with 4 containers, which means we can store a maximum of 4 items in this shelf, right? So for arrays, we define the size of an array in the same way. So if we can store 1, 2, 3, 4 items in an array, we say the size of array is 4, essentially telling us the capacity of that array. Now, how do I refer to a certain container on the shelf? Let's say I want to know what is stored in this container. So when I'm explaining to you, I'm using this arrow to indicate that, but how do we write it down? How do you refer to someone who is not seeing this screen? So one way of doing it, we can say, okay, start counting from left on the shelf and go to 1 to third container and see what's in there, right? So we can use a number or an ID or an index per se to refer to one of the containers that is being stored on this shelf. Now, this is the same idea for array. For arrays, if we have multiple items, as we said, it's a collection of items. Let's say we have one item in each of these cells. We can say, okay, we can refer to them starting at index 1, and then progressively as this goes to the right, we increase the count by 1. So that means if I say get me the element at index number 1, the program will be looking into this one. If I say give me the element at index 3, it's gonna go, okay, this is 1, 2, 3. It's gonna go to number 3 and extract that information, or um, assign a new number, or whatever the operation we want to do with that array element at that particular moment. Now, for example, coming back to the grocery shelf analogy, let's say we are putting out items in each of these containers now. I'm going to put flour at index number 1 or container number 1. I'm going to put egg in container number 2. I'm going to put rice in container number 3, beans at container number 4. So this becomes a way easy to handle the information if we use indices like that, right? So we have a clear way of referring to a particular element in our shelf. The same way, if our array is storing or working as a collection of, let's say, 4 different numbers, when we are assigning, we can say, okay, add number 35 at index number 2. So the program knows exactly where it should store that number. If we say, give me the number at index number 3. So now the program knows which number to extract, and it's going to return me 68, right? The main idea I want to take from this slide is, if you have a set of containers to store different items or groceries, as long as you have an index to refer to them, right, you can always access the contents of that container, right? For example, if I say, okay, I want to access the index. Oops, let me go back. Sorry about that. So now if I want to get the contents at index number 3, the program knows I'm asking for rice, right? So what is the index in this case? Number 3. And what is the value or the content? That is rice, right? Similarly for array, if I say, okay, give me the content at index number 2. So this is the index number, but what is the value? The value is 35, right? So if you compare that with a regular variable in MATLAB, let's say my variable name is V, and I was storing this number 35 in that variable. Now, if V is an array, right? If instead of this way, I'm actually saying this is my V now, which actually contain 1, 2, 3, 4 items, right? So that means if I'm referring to V now, I'm actually referring to all of these 4 items. I'm referring to a collection. But from the collection, if I want to access an individual item, I need to give MATLAB another piece of information, which is the index number. So if I want to access index number 3, I have to tell MATLAB, okay, give me index number 3 from array V. This is the only way MATLAB can tell me, okay, the value is 68 this time, right? So again, the main takeaway from this slide is the relation between index and values in case of array, okay? So whenever you are dealing with array, remember you have two different aspects to deal about. To refer to a particular element, you will need an index. And if you want to know what is stored in that location, let's say these values, um, that will be the content of the array. Okay, let's continue. Now let's say, how can we create or initialize an array in MATLAB? There are actually several ways of doing that. So let's see the most common ones. We'll use 3 methods to generate arrays. So let's get into MATLAB. Let me minimize this window. Okay, so if you are doing your in-class assignment right now, I advise you to type in diary on command, so which basically opens the log for you, whatever typing you make in the command window that gets stored. And I want you to upload this file at the end of the lesson as your assignment. So just hit that, and that's going to create a diary file for you in your directory. If you are just watching the video, you can ignore this command. Okay. The first way to initialize an array is actually straightforward, and in this case, you would know what numbers you are going to store in your array. Okay, so let's do that. And before we do this, remember we have said that it's a good idea to clear your command window and your workspace. I already have some commands from earlier, and also my workspace have some variables. We don't want any conflict. So I'll just type in clear and CLC to clear up the command window and the workspace. Okay. However, the commands will be still being saved in the diary file. Okay. All right. Now, to create an array, the first thing we have to do is give the array a name. So in this case, I said the array name is array example 1. Okay. So what I want to show you here is that you can start the name of array with a text, okay, with a letter. You can use small or capital, but the convention is to start with a small letter and then keep going on. You are not allowed to have space. So I used underscore in the place of space. You can put a number in between, but remember you cannot use a number or a symbol to start the name of an array. Okay, so once I do that, I have to put the equal sign to assign a value. To enter the array, I have to put the box bracket right here. That way MATLAB knows whatever I'm typing in right now, it's gonna be an array, right? So let's put out the numbers. So the first element is 12. The second element is 32. To differentiate one element from the next one, we can use space or we can use comma. For this example, I'm using space. Okay, so I put space again and I put 54. Then I need to close the square bracket. So I hit enter. You see an array with 3 elements has been created with values 12, 32, 54. And you can also see that in the workspace, I have an array named array example 1, which contains values 12, 32, and 54. So which is different from a regular variable, which would hold only one value, right? Instead, we are having a collection of 3 values. Okay. So this is really easy, right? And this works well when you have a limited number of elements to type in, or you have the contents of the array already prepared, maybe in a file or being fed from another program. But if you're just creating the array from scratch and you have to create, let's say, a series of numbers, and you have to generate maybe 50, 100 numbers, this would not be the, or at least a very efficient way of doing that, right? So let's just see some example of how to deal with those kind of situation. So the second example I have on the slide is actually one of those cases. So for this example, let's say we know what should be the starting value of the series, and we know how much difference should be between each numbers, right? And then we know a cutoff or terminating value. So for the example I have on the screen, I have an initial value of 0. That means the series I'm going to generate and store in the array will have a value of 0. That's why it starts. And for the next value, it will increase by 20. So my next value will be 20, right? What should be my next value is 40. So it will keep adding 20 and create a new number until it reaches the terminating value, which is 100 in this case. So it will go to 0, 20, 40, 60, 70, 80, 100, and then it will stop, right? So it has reached its terminating value right there. Okay, now let's type that in MATLAB. Okay, so in this case, I want to use a different array name, array example 2 equal to the way to generate or put that information we just talked about is first you have to type the starting value. Okay, so in this case, which is 0, I can put colon, and then I have to type the step size or the increment value, okay, which is 20, and then I have to enter the terminating value, which is 100 in this case. So you see, MATLAB has created an array with the elements that we want. Okay, now if you think about this, we did not really know or tell MATLAB how many numbers MATLAB should generate, right? We told MATLAB where it should start and how much it should increase at each stage, and then we told it the program when to stop, right? Okay. So MATLAB actually decided the number of items by itself based on the information we provided. Okay. Let's actually change this array example to something else. Okay, I want to use this as an example to demonstrate what do I mean by terminating value. So let's say I'm putting out an array example and I put equal to 0 to 20 to 99. Okay. Now, if you notice, for this example, my starting value was 0. So the first value on the array was 0. The program terminated at 100 and the last item on my array is 102. Now, if you are generating your array based on this command, this does not guarantee that the last item on your array will be 100. What do I mean by that is it focuses where it should start and then it keeps adding 20, right? Now, if I had a value less than 100, let's say 99, which is not a multiple of 20, let's say it start from 0, adds 20, adds 20, adds 20, adds 20, and then 80 plus 20 is 100. But what if we limited the terminating value to 99? Is it gonna add 99 to the array? That's a question will be answered in a second. Okay, but it certainly cannot go to 100 because we said the terminating value is 99. Okay, all right, so once I enter that, MATLAB created a new array with 1, 2, 3, 4, 5 items, right? So it did not include 100. So what that means is MATLAB starts from 0, it keeps adding 20, right? And it keeps adding a new number with an incremental value of 20 until it reaches 99. Say we start from 0, right? Let me pick up my pen here. Okay, so we start from 0 and then we have 20. So each time it adds or gets a new number before adding it to our array, it checks that with the terminating value here. Okay, so is my number greater than terminating value? Is 20 greater than the terminating value in this case? No. So 20 is good to go. It does that same for 40, 60, 80. what is the next number in the series we have after 80? So 80 plus 20 is 100. Now, is 100 greater than 99? So it does that. It goes to 80, and then the next number is 100. Is 100 greater than 99? Yes. So that means the program will no longer continue and it will not add 100 because it already violated the terminating condition. Okay. So this value is not necessarily be included in your array. It just means where the program stops adding new numbers. Okay. But there can be cases where the terminating value is actually a multiple of step size. For example, the previous example we did in here. So that will be a special case. But the meaning of this last number of the command is actually it's a terminal value. It's not the last value that should appear on the array. The reason I'm stressing that is because that's actually a key difference between the next way of initializing an array we are going to learn. Okay, so this will all add up in a moment. The next item on our list is using linspace command. Okay, so we have that right here. So in this case also we are looking for a series of number, and we know, or we should know, the starting number. Okay, we should know the n number, and we should know how many numbers we want between these two numbers. Okay, so for example, I want my array to start at 0. I want it to finish, or the last value on my array should be 100. And in between, I want 6. Oh, actually, not in between 6. Including the start and end value, I want a total of 6 items that are placed at a um, at the same distance between each other. Okay, so we call that linear spacing. So I want 6 items, 6 numbers between 0 and 100 which are linearly spaced. That means the difference between any two consecutive numbers should be same. Okay, so they are equally spaced. All right, now am I telling MATLAB what should be that difference? No, I'm not. I'm just saying, okay, you should start at 0 and you should finish exactly at 100, and you should give me a total of 6 numbers in that array which are equally spaced. Let's see how that plays out in MATLAB. So I'm going to the command window again, and I'm saying array underscore example 3 in this case. So I put the equal sign, and then I have to write lin space, which abbreviates for linear space, put the parenthesis on, and then the first item I have to write in is actually the starting value of my array. So I put 0, and the next value I have to type in is the end value of my array. So I put 100, and then it's asking me how many numbers should be generated. So I'm saying 6. All right, now let's close that parenthesis and enter the command. So it has generated 0, 20, 40, 60, 80, 100, which is essentially the same matrix or same array we generated earlier, right? Now, what about, let's say I want to use the same array name, okay? And Instead of 100, I want to use 99 now. Okay. So because I used the same name again, MATLAB actually replaced the value in the workspace with the new values. So if I'm referring to array example 3 now, it will take the new values. It's no longer going to use the old values in the array. All right. So this happens for MATLAB for any variable or array. If you use the same name again and reassign a new number, it will replace the old values. Okay. So I said, okay, for some reason I put a period down there. Let me just fix that, although it will not probably make any difference in the answer, but let's remove that anyway. Okay, so I should write array example 3 equal to linspace starting value, ending value, and number of elements or numbers I want to generate. So it started from 0, it went until 99. So you see the difference of this between with the last method we learned. So in this case, this is guaranteed that the first element of the array will be 0 and the last element of the array will be 99. And we will have 1, 2, 3, 4, 5, 6 elements. Okay, but do we know or did we tell MATLAB what should be the difference between two numbers? We did not. So MATLAB has the freedom to calculate that what difference it should create between consecutive two items to make 6 items equally spaced between the initial or starting value and the end value. Okay, so you see the difference of these two methods we learned. In the first one, let me get my pen. Okay, so in the first one, what we learned is we give MATLAB the first number where to start, and then we give MATLAB the step size, and we tell MATLAB a terminating number. Okay, so MATLAB starts from a number, it goes on with a step size, let's say 20. We don't know how many numbers it's going to generate right away. So MATLAB has the freedom to choose how many numbers it has to generate while adding 20 each time as it adds up a new element, okay, until the program stops and it reaches an ending value. Okay, so for this example, the ending value was 100, so it will stop at 100. But for the other example we saw, it was going on until it reached 99. But because after it reached 80, right, the next available number is 100, right? Now, if my terminal value is 99, the program will not add 100 in that case, neither it will add 99, because based on this condition, the next available number is 100, right? So 99 is not part of that criteria, right? So it's actually satisfying two different criteria at the same time. Okay, it has to be a multiple, or it has to satisfy the condition that it has to match that incremental value, okay, with the previous number, from the previous number, and also it has to satisfy that the current number does not exceed the terminating value we defined. All right, now let's come to the other method. So for this one, it's we are telling MATLAB what should be the first value. We are telling MATLAB, oh, I should not use colon here. Let me just erase that. Get my pen back. So I'll say first, and I want MATLAB to know my end value. Okay, and I want MATLAB to know the number of items it has to generate. So you can say number count. Okay. So in this case, we are telling MATLAB where to start, same as before. But in this case, we are telling MATLAB which should be the ending value of the array. Okay, so this is different than earlier. Earlier we said we are telling MATLAB the terminating value, but this time we are saying what should be the last item on in my array. Okay, so for example, when we said 99, MATLAB did add 99 as the last item in the array. And then the next thing we have to tell MATLAB is how many items we want in that array, right? That means we are not telling MATLAB what should be the step size in this case. MATLAB sort of decides that by itself. So that's the key differences between these two methods. Now, which of these three methods you use to initialize an array, that really depends on your scenario, the kind of situation you are in, what you need, right? So you will know based on the circumstances, whichever is most convenient to you, you can use that. Okay, there is no problem with that. Now that we have initialized several arrays, let's see how can we access them. Okay, so let's recreate the array underscore example, okay, with a new value or new set of values. So let's say I type in array underscore example equal to start square bracket 20, 10, 50, 65. I close the square bracket, type that in. So I have my array ready. All right. Now, as we spoke before, to access an individual item or part of the array, I actually have to know the index of that item. Okay. So for example, if I want to know what is the value of second item on this array, and when we count, we start from 1 and we start from left. So the first item is 20, second item is 10, third item is 50. So if I want to use this number, okay, or I want to know the value of this, I have to type the variable name first, okay, and then in the parenthesis, I have to type in the index number. So let's say if I'm looking for the second index, this is what I'm gonna get, right? So the same thing can be repeated for item number 3. We get the number as answer from MATLAB. Now we can also assign this value to another variable, or we can use that for calculation. So for example, if I say, okay, my variable name is t and I'm storing the third element of my array in this variable. So I have t as 50 now, right? And if I have another variable, let's say a equal to array underscore example, and maybe I'm accessing the item at the index 1. So I have that. So I can use these numbers actually for doing some other calculation. Let's say if I want to know t plus a, that takes the command and gives me the answer, right? We can also use the values, individual values from the array directly into some calculation. For example, array example, and I pick the item number 2 and I put a plus sign. Then I put array underscore example and maybe I put 4. Okay. So that's going to return me the sum of those two numbers. All right. Now let's say if I want to change a number or an element on the at a given index of the array. Okay. Um, so again, you have to know the index number for sure. So I'll say array underscore example, and then I have to type in the index number the same way we accessed the value, but this time I have to put the equal sign, which means I'm assigning a value at this location, and let's say I'm changing that to 90. Okay. Pay attention to the value on the left of the screen. In the workspace, you see the old values are 2, 20, 10, 50, and 65. So once I do this, the remaining three values are same as before, right? But at the fourth index, we had 65 before. The new value is 90. So you can actually change an individual um, number or an element on in the array if you know the index number. Okay. Um, so that's good so far. So now there is another way you can actually access part of an array. So let's say we had 4 items in here. So far we know how to access one individual item from the array. We can actually take part of this array and create a subsection of the array. Okay. The way to do that is you type in this variable name the same way we accessed an individual number or value, but in this case we have to give a range of numbers. Okay. So let's say I want to access the values starting at index 1 to index 3. Okay. So I have to type in the variable name same way. I have to put on parentheses, and inside parentheses I put the starting index and I put the last index. Okay. So this reads out array example index 1 2 3. Okay. So it accessed 20 10 50, but it excluded 90. So if you need to use a part of an array for some operation, you can just extract part of that without having to access all the necessary items one by one. You can extract them as a block. Okay, so it just saves you a few extra lines of codes. Okay, so let's clear up the command window and workspace again before we get into the next examples. Clear CLC. So that cleaned up my workspace and command window. But don't worry, you have everything saved in the diary file if you typed in diary on at the beginning. Okay. All right. So let's go ahead and see the next topic on our list. This time we want to know about multidimensional array. Okay. And I want to use the same analogy of the grocery shelf to explain this concept. So it's very similar like before. We have a shelf of groceries which has flour, egg, rice, bean, and we can refer to them with container number 1, 2, 3. Okay, except we are using two shelf, sorry, yeah, two shelves of the storage. So this is shelf number 1 and this is shelf number 2. Okay, or rack 1, rack 2. And then we have the containers arranged in chambers like this. So it's like probably a shelf that has boxes set up like this, like a grid, right? So you can think of this arrangement as a tabular form, right? It has rows which are indicated by shelves, and then it has columns which are indicated by container numbers, right? So we can now, is there a problem now? Well, a small problem, because if I say get me the item from container number 1, okay, let's say container 1. Now you came to container number 1, but there are actually two container 1. In this shelf, we have container number 1, we have container number 2, we have container number 3, we have container number 4. Similarly, in the other shelf, we have container number 4, 3, 2, 1. Now, if I tell you get me the item from container number 1, the problem is there are actually two container 1. Okay. Now we have to somehow include the reference of their shelf inside the index, right? So the way to do that is to refer to these cells as a table. Okay. In the table, if I say, okay, what is the cell location for this one? So we have row 1 and column 1, right? What about this one? We have row 1, column 2. So the similar way, we can say shelf 1, shelf 2. So if I say I want to access this container, what I have to say is go to shelf 1 and container 2. Well, actually, I made a mistake. This should be shelf number 2. So you have to go to shelf number 2 and container number 2. So you can translate that as you have to go to row number 2 and column number 2, right? So any further reference we make from here has to use actually two index. They have to use an index for row and they have to use an index for column. Okay. So like before we said, okay, get us the item at this location. So we'll refer that as, okay, give me the, let's say my array name is item. I'll say get me the item at shelf number 2, container number 4. So this is how we can use two different indices to mention location of one container, right? Like a 2D map. You have to give me the X location and Y location to get an exact point on a 2D map or graph, right? So we can translate that into the concept of array very easily. So now you will think of array as tables, okay? For the first row, we have 28, 35, 68, 96. But we have a new row now, which is part of the same array, okay, which is 20, which has value of 28, 35, 68, 96 as their values. Let me actually change these values so that you can differentiate. So now if I want to refer to, excuse me, okay, refer to this cell right here, I have to indicate the array name first. Let's say my array name is ARR. Okay. So the first index I have to put is the row number. What is the row number for 35? 1. What is the column number? 2. So I have to put a comma and I can put 2. So this way MATLAB knows where exactly to look. If I want to refer to this cell right here, I have to write the variable name. And what is the row number in this case? Row number is 2. What is the column number? 3. Right? So if you have to, so this will refer to the element that has 71 in this case. So anytime you are referring to a 2D, two-dimensional array that has rows and columns, you will put the row number and the column number inside the parenthesis this time. Okay. Now MATLAB actually allows us to create arrays in more than 2 dimension. Virtually, it can actually be any number, right? So, but we are not getting into that example because I cannot show you that on a 2D screen. But virtually, MATLAB can actually create more than 2 dimensions. It can create 3, 4, 5 dimensions if we need them. Okay. So just for quick exercise, try to think of how can you refer to um, the blue cell, okay, right here, using 2-dimensional array index system. How can you refer to the blue one? How can you refer to the yellow cells? How can you refer to the green cells? Okay, I'll leave that up to you. Um, just for your exercise, you can pause the video for a moment and see what is the size of this array in terms of number of rows and columns, and try to refer to this blue cell, try to refer to these yellow ones, try to refer to these green ones by yourself. Okay. Now let's move on. Let's see how can we initialize this kind of multidimensional array. All right. Now, as you can see on the slide, we actually have many ways of doing that, and I'm going to show you 5 different ways. So let's get back to MATLAB. The first way is actually very straightforward, like before. If you know all the numbers or values or the contents you are gonna put into MATLAB, I'm sorry, into your array, all you have to do is just type in the name of the array, put the equal sign, start square bracket, type in your numbers, okay? But just remember that if you put space between 2 numbers, that lets MATLAB know the item will be placed in the next column. So I put 12, okay? I put space, I put 32. That means 32 will be placed in the same row, but next column. I put space and I put 54. So 54 will be added to the same row, but to the next column. Now, if I want to go to the next row, I have to put semicolon. Okay. So once I put that, MATLAB knows this is the end of this row and it will start on a new row. Okay. So on the new row, I have to type in my column values again. So 36, 62, 47, and then I have to close the square bracket once I'm done. Okay. So I have this 2-dimensional array now, which has 12, 32, 54 that was separated in by space when I was typing in. And once I put that semicolon down there, it went to a new row and put the 36, 62, 47 in their um, appropriate columns, right? So the key idea here is because we are using 2-dimensional arrays, you have to use this semicolon to tell MATLAB that you are going to a new row. Okay, so to give MATLAB the information that you are adding information to a new column, we use space and semicolon for new row. Okay. Now we could also create a column matrix, or let's say 1-dimensional array which has only columns instead of rows. So far when we typed in, let's say, array arr equal to 10, 12, 13, that was created as an array with 1 row and 3 columns. So this is what we call the dimension of array. The dimension of this array is 1 by 3. That means it has 1 row and 3 columns. Okay. Um, However, if I type that information as 10 semicolon 12 semicolon 13 and close that square bracket, this will be added as a column vector, right? So it has 10. Because of the semicolon, it's going to a new row. Because of the next semicolon, it went to a new row. So I have 3 rows and 1 column. So the dimension of this array is 3 by 1. Okay. We can also see that from the workspace actually. So if I double click on this ARRY, it says it's a 3 by 1 array. So that means it has 3 rows and 1 column, right? Now if I open the 2-dimensional array, it says it's a 2 by 3 array. So that means it has 2 rows and 3 columns. Okay. Let's close this stuff and get MATLAB to the right screen size. Okay. Now we can also utilize the function we learned earlier, where we knew the starting value, we knew the incremental value, and we knew the terminating value. Okay. Let's say I want to use this, and now we are dealing with the second way of creating an 2D array. Let me get my pen. Okay. So we're talking about the case where we knew the start value, we knew the increment value or the step size, and we knew the terminating value. Okay. I guess terminating value would be a better phrase for this instead of end, because we are not actually putting the end value here, we are putting the terminating value. All right. So we do that for the first dimension, and then we put a semicolon and we put the second dimension here. Let's type this command in the MATLAB command window and see how that generates the matrix for us. Okay. So when we say matrix, we are actually referring to 2-dimensional array here. Okay. They are array, they are also matrix because they are being organized in number of rows and columns. Okay. So the name of my array, let's say I'm picking array example 2 in this case. The starting value for first dimension, which is rows, is 0 to 20 to 100, and I'm putting the semicolon to tell MATLAB to go to the next dimension. This time I'm putting start at 0, increment value 2, and terminating value 10. Okay. Now the output I see here is actually having only 1 row. That's because I made a syntax error. Okay. So once I said 0, start at 0, get the increment value of 20, terminating value 100, and then I put the semicolon. I say start at 0, step size 2, and the terminating value 10. MATLAB actually executed both of them, but returned me the output for the last one only. What that means is when I put this semicolon, for commands, if I use semicolon, what it does, it actually suppresses the output. Okay. I want you to learn from my mistake here. So if I put this, that means MATLAB executed this line first, but it suppressed the output because of the semicolon. Now, when it went for the next one, it picked this variable name again and assigned, I'm sorry, so it did not actually pick up this variable name again. It just left that alone. Okay. How can I tell that? If you look on the workspace, it has 0, 20, 40, 60, 80, 100, right? So that's what the first part was supposed to do. And for the second one, it did not store inside this variable at all. It ran as an independent command and gave me output in the command window. Okay, so it was executing as if this part is one command and this part is one command. That's because I did not tell MATLAB that I'm actually entering an array and it should behave as if I'm entering this command as one single command, not two commands written in the same line. Okay, so the way to fix that is I have to go to array example 2 and put that square bracket in. Only that way MATLAB knows I'm actually entering an array, okay, of 2 dimension. So if I do that, what it did for the first row, it generated 0 to 20, sorry, 0 to 100, and it maintained the step size of 20. And I put that semicolon, which means go to the next row. And then inside that row, it generated numbers between 0 to 10 with step size of 2. Okay. If I put another semicolon here and put another series, it's gonna actually create that array for us. Okay. Let's say if I write array example 2, and I can actually combine 3 different types of generation or initialization technique in the same array for different dimensions. Let's say my first row is this, I put the semicolon, and then second row is generated by this. The third row I actually want to type in. So 35, 65, 41. Okay, just for example. Now it looks like I got an error. And let's analyze that problem. So it says dimensions of array being concatenated and are not consistent. So what that means is when I say 0, start from 0, use step size 20, and the terminating value is 100, MATLAB generated 1, 2, 3, 4, 5, 6 items in one row. For that second item, it has 0, 2, 4, sorry, for second row, it had 0, 2, 4, 6, 8, and 10. Okay, but if you think about the command I entered, I had 35, 65, 41. How many numbers I have there? 3. So this is not allowed. You have to maintain a consistency of number of dimension. What was the number of columns I had? 6. Number of rows were 2, but since I'm using this, I will add a new row, but that new row is going to contain 35, 65, 41. But what about rest of the 3 columns? We cannot just hang it, let MATLAB hang with that. So we have to actually let MATLAB know, okay, I don't have a number, maybe, oops, I don't have a number, maybe just put zeros, 30, okay, and enter. Now this worked, okay. So the takeaway from this is you have to maintain consistency of size of dimensions. If you don't have any number, you can maybe put an unusual number or a character inside that to let your program know that it's a different type of value, that you did not have that information or something like that. Okay, but you cannot leave MATLAB undecided. You have to put some information down there. And you have to make sure that you are maintaining consistency of dimensions. So you are having 3 rows now. First 2 are generated using this technique, and the third one had actually typed in numbers for initialization. Okay, all right. Now let's see the next way to initialize the array. So this time we can use linear space, and this is the very same way we did for the one-dimensional arrays. So let's just type in the command array underscore example3 is equal to, we have to start with the square bracket, remember that, lin space, that means linearly spaced items between 0 and 100. We want 6 items. I can put the semicolon, linear space. I know on the slide it says different numbers, but let's just say from 0 to 10 with 6 items. Okay, and close the square bracket. Type in, and we have our array of 2 rows and 1, 2, 3, 4, 5, 6 columns, right? Let me actually upgrade my PowerPoint right there because it has the same syntax error for example 3. Okay, I actually upgraded the PowerPoint. If you notice now, it has the square bracket at the beginning and at the end for both of these two methods. Also, I have changed this wording from end value to terminal value. Okay, term means terminal value, so that would make better sense. So just remember that you have to use the square brackets to tell MATLAB that you are entering an array when using these two techniques. If you think about that, we're actually using this similar concept as this one to tell MATLAB about new rows or columns using the semicolon, right? So this is imperative that you should be using those square brackets anyway. All right, now let's get back to MATLAB. About the lin space command, we already talked about this when we dealt with one-dimensional array with single row. So I'm not gonna repeat that. Hope you understood that from earlier. So let's look at the fourth way of initializing an array. So sometimes we don't know, or we don't have the information about the content of the array at the beginning. So as the program runs or progresses, it sort of gets the feed from some other part of the program and stores those values inside the array. So how to initialize an array in that situation? So there are two functions in MATLAB called zeros and ones, which, as the name dictates, for zeros it initializes the array with a value 0 in each of the element of array, and for ones it initializes the array with 1 in each of the element of the array. Let's see the example. So let's say I want an array example 4. Okay, let's say I type in zeros, okay, and put the parentheses. Now remember, the zeros syntax does not have an E after O. Okay, this is a very common mistake people does, is type in 0, put an E because it's an O. So that plural, singular plural thing in grammar, English grammar, does not apply here. Okay, so we say zeros and ones. And when I put that there, I have to put the row index and the column index. That means I'm setting the dimension of this array. So let's say if I'm saying 5, 3, that means this array will have 5 rows and 3 columns. Okay, and each of them will have value of 0. We have the array created, and we have 1, 2, 3, 4, 5 rows, 1, 2, 3 columns, where each of the element has an initial value of 0. Okay, so this is how we initialize the array, and then later as the program runs, we probably update some of these values to certain values, right? Whatever comes out from our calculation or whatever the program decides. We can use ones the similar way. So I can say array example 5 equal to ones, and I can type in 5 3. Okay, so that means it's going to create an array with 5 rows and 3 columns, and all of them will have a value of 1 in each element. Okay. There is another use of the zeros and ones functions. So if I type in zeros and I say 5, what it does is it's not going to create an one-dimensional array with 5 elements. What it will do, it will actually create a two-dimensional array with 5 rows and 5 columns. So this is a shortcut if you want to create zeros or ones matrix where the number of rows and number of columns are same. Instead of writing zeros 5 comma 5, you can actually just write zeros 5. Zeros 5 comma 5 will work just fine. Okay. um, this is just a shorthand, so you can use either of them, and that applies to ones too. So if I type in ones and I type in 5, created a 5 by 5 matrix for me with 1 as value in each of the elements. Okay, now let's clear my workspace and command window. Okay, let's just clean that up. And now let's see how can we access information from a two-dimensional array. Okay. So let's create the array example I have on the slide. Array underscore example. I start with square bracket. I type in the numbers. Once I'm done typing in, I can just close the square bracket and hit enter. So that's gonna create this 3 by 4 matrix for me, or array. So if I ask you what is the dimension of this array down here, it should be 3 by 4 because it has 3 rows and 4 columns. So the first item means number of rows, second item means number of columns. You can also see that here it says 3 by 4 double, right? So if I double click on that, it's going to open the variable in the workspace, and you see it saved that as a table. Okay, so it has 3 rows again and 4 columns. Okay, let's just close that and minimize MATLAB. Let's see. Now the next item we have on our table is picking up certain number from this array. Okay, so when it was one dimensional, we would use one index, and because we have two-dimensional array, we have to use two different indices. Okay, if I say array underscore example, I put the parenthesis on, and I have to put the row index, I have to put the column index. So that means give me the item or element at index row 2 column 3. Okay, so it gave me 65. So let's verify that. Row 2 is this, and then column 3 is 1 2 3 this. So 65 should be the right answer, and MATLAB gave me 65. Okay. How do we assign certain number to a specific location? Okay. What we can do is we can use array underscore example name again, and then we have to give MATLAB the index at the place I want to make that change. So for the example on the PowerPoint, we have location 3 1. That means column number 3, sorry, row number 3 and column number 1. So equal to 60. All right, now if I type in this, what should happen is that if you look into this little window down here, my current value at row 3 and column 1 is 63. So once I type in this command, it should change to 60. Okay, let's see if that happens. So I typed that in, it kept all of the array undisturbed, and it just changed this specific location at column row number 3 and column number 1. Okay, so if you put that exact index and put an equal sign, put a number next to it, it's going to assign that to that number or text to that specific location on the array, the same way it would do for any variable, right? The next thing we're going to learn is a little bit tricky. So we can also use a single index to refer to items in multi-dimensional array. Okay, um, but it's there is little more to that than just typing in the um, index as we understood in terms of by number of rows and by number of columns. Okay, so let me increase the size of this PowerPoint. Let's actually make that full screen. Okay, and we are talking about this example now. Okay. So this goes to back to the fact that whenever you are storing a set of numbers, let's say two-dimensional um, array, um, the way we see it is we see this nice number of rows and number of columns. But when MATLAB stores this in the computer, it does not have that privilege to save them like a table. Okay, you just have empty spaces in the register or the memory, and you just have to put in these numbers down there. Okay, so the way MATLAB stores this in the memory is actually it picks the first column of this table or array and puts them in one block. Okay, in memory cells next to each other. So it puts 20, 51, 63. The next item it starts is the following column. So 10, 23, 12, 10, 23, 12. The next item it stores is 50, 65, 54, 50, 65, 54. The next item it stores is 65, 14, and 12. Okay. So this is how it saves those in a group of cells in the computer memory. And it maintains this sequence so that when you calls upon an specific item of the array, it can pull that from this collection, right? Now it keeps a map of this one-dimensional collection so that it can convert that to rows and columns when you call or when you try to do certain operation with the MATLAB using two-dimensional index. Okay, so that it's easier for us humans to interpret that. So if you are using an one-dimensional array, let's say array example 9, and that exceeds the number of column in here, what it will do, it will go and count these items in this sequence as if they are stored in one single column. Okay, so when I said array example 9, what it will do is on the table perspective, it will go to the first item, second item, third item, fourth item will be the first item of the next column. So fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th. Okay. And on the memory perspective, it will go to 1, 2, 3, next column, 4, 5, 6, next column, 7, 8, 9. So it will actually pull this value 54 from the memory, right? So if you are entering only one index, you have to be really careful because MATLAB is not gonna put that or give you an error because you are entering one single number instead of the two-dimensional format. Because there is a way MATLAB can interpret and map this to the memory, okay, so that it can access certain items of your array. And the way it works is it arranges this set of columns next to each other, one after the other. So this guy actually comes down below here. This guy actually comes down below here. This guy actually comes down below here. Okay, and then it starts counting. Okay, so this is 1, this is 2, this is 3, this one is 4, 5, 6, 7, 8, 9, 10, 11, 12. If it helps you, you can also refer to this one. So MATLAB does that mapping for you and gives you the result. So if you are doing this by mistake, you will not get an error. But if you intentionally do that, you can really take advantage of this way of accessing array items in particular situation. Okay. Now let's try that in MATLAB. Let's clear the annotations. So the way I have to do that is I have to type in the variable name one more time, array example, and instead of 2 index I have to put 9. That means it will go to the 9th item as if it was a linear combination, the as if the numbers were arranged in one single column. Okay, concatenating one column after at the end of the other. So if I type in array underscore example and put the index as 9, MATLAB is returning me 54. So that's what it should give me, right? All right. Now we can pick up a part of an array the same way we did for one-dimensional array, but this time we have to put 2 dimensions, right? To do that, all you have to do is type in the array name, put the range for the first dimension. So from which row to which row you want to extract, right? And then put the comma, then from which column to which column you want. So if I want row number 1 to row number 2, and then if I want column number 2 to column number 4, okay, let me pick my pen. What we are referring here is I want row number 1 to row number 2. That means I want, oops, that's too thick. I want this row and I want this row number 1 and 2, right? And then fix this, okay. And then I want from column number 2 to column number 4. This is column number 2, this is column number 3, this is column number 4. Okay, so based on this, the part of the array I want to extract is whatever is inside this box, right? So I go to row number 1 and 2, I go to column number 2, 3, and 4. So this is what I need to see on my screen, or use that for any other purpose later. Okay, so I already have my command typed in. I just hit enter, and that's what I get. Right? You can match that real quick. Okay, let me clear up the annotations. Before we go to the next slide, there is one thing I forgot to show you when I was telling you about the zeros and ones function. So if you want to generate matrix with more than 2 dimensions, maybe 3, 4, 5, 6, infinite, you have to type in zeros, and then you can put on the size of the first dimension, right? So talking about number of rows, number of columns. So in third dimension, it will be something else, right? So the size of, when we say number of rows, that's the size of dimension in terms of rows. When we say number of columns, that's the size of the dimension in terms of columns. So for the first dimension, I say, okay, I want 3. For the second dimension, I want size 4. For the third dimension, I want 6. For the fourth dimension, I want 2. Okay. Now when I type that in, okay, MATLAB is actually giving me a crazy output right now. And the reason for that is it's not 2-dimensional, so that MATLAB can just print that on my screen. Okay, it's 4-dimensional, as you can see in here. Answer is 4-dimensional double. If I double click on that, it's not a straightforward matrix. Okay, it's breaking up that and putting a part of it at a time. So that's just for you to know that you can create matrix or matrices with more than 2 dimensions if you need them. Okay. Coming back to the array example. So I had this answer in my last example. Now let's bring back the original array example again, so that I have 3 rows and 4 columns. Okay, so what I have to do now is I want to show you a trick about the range of dimension as we use when selecting part of the array. Okay, so I can put array example as the name, and then in the parentheses I was supposed to type in the range of my rows and range of my columns separated by comma, right? So instead of typing in range 1 to 3 and maybe column, let's say 2 to 3. Okay, now what this is gonna do, it's gonna actually give me back all 3 rows and column number 2 and 3. Oops, I made a mistake. I put extra parentheses. So let's get rid of that and type that in. Okay, so we have a part of the original matrix now. So the trick here is when you need to access all of the rows or all of the columns, you can just put colon instead of typing this range. Okay, instead of writing 1 to 3, I could just type in colon. That means I can go to array example, I can get rid of these 2 index and just put colon. Okay, so that's gonna give me the same answer. So what this colon means, if you don't put a number before or after colon, that means include all. Okay, and I put colon in the place where I should write the range for rows, right? So that means include all rows, but include rows include include columns from 2 to 3, right? What if I say colon in both indices? So that means include all rows and include all columns. So that's basically going to bring me back the whole matrix again. What if I want row 1 to 2 and I want all columns? So it return me first 2 rows and return me all columns. So if you just type in one number, let me go back to PowerPoint. So if you type in one number in the row place, so when you are calling out or accessing an array, if you are entering a single number in the place of row and single number in the column, it's going to pick up one single item from the array, right? And if you are using a colon between 2 numbers, put a comma and enter the column same way, it's going to give you a subset of this array, right? So you put the beginning number of row, put colon, and then put the ending number of row, put comma, put the beginning number of column, put a colon, put the ending number of column. Okay, so this way, this particular part of the array will be extracted from the array. All right. Now let's move on. Now that we have learned how to initialize, access, or manipulate arrays, let's learn how to actually put that into some use. All right. So let's start by clearing up my command window and workspace one more time. Okay, and create these two matrices on MATLAB. How can I do that? I have to enter A to put the box bracket, 20, 10 separated by semicolon, 30, 40. Okay, I can put a semicolon after that to suppress the output. B equal to, and put the box bracket, 10, 20, semicolon, 5 and 10. Okay, enter. All right, so it created two matrices A and B in the workspace with the values I've given. So B is already showing on the command window because I did not suppress that output. If I type in A, it will show me the values of A as well. Okay. So when we store these numbers in array, they are basically an arrangement, right? If I want to add these numbers or these two arrays, what it does is it picks out one item from each array. So if I say A plus B, what it does is it picks out the first value of this array and adds that to the first value of the next array. It goes to the next item, it adds 10 to 20. It goes to the next index, picks out 30, adds that to 5. It picks out the next item, it picks that and adds to 10. Okay, so what that means is it will do these operations item wise. The first item of first column and first row of the first matrix will be added to the first row and first column item of array B. Similarly, the second column, first row, second columns item will be added to first row, second column item of array B. Okay, that means if I type in A plus B, it should give me something like, oops, I'm sorry. Okay, it should give me 30, 30. So 20 plus 10 is 30, 10 plus 20 is 30, 30 plus 5 is 35, 40 plus 10 is 50. Okay, so on this example on the PowerPoint, I have B plus A. So addition works the same way whether you type in A plus B or B plus A, so it should give me the same result anyway. Okay, now I can do subtraction the same way. If I say B minus A, so that's gonna pick out a number from B and subtract the number from array A at the same location. Remember, it will keep the consistency of the location. So 10 minus 20 is minus 10, 20 minus 10 is 10, 5 minus 30 is minus 25, 10 minus 40 is minus 30, right? So it's doing that item by item, which is great. So if you have two matrices and values organized in certain way for given purpose, you can actually add them or subtract them item by item. All right, so MATLAB already has the program ready for you to do that. And if I continue, oops, let's try B times A. All right, now do we have any problem? look at the screen and think about it, okay? So based on the idea for addition and subtraction, if I multiply this, what MATLAB should do is pick the first item on matrix A and first item of matrix or array B and multiply them. So 20 times 100 is actually 200. 10 times 20 is also 200. 30 times 5 is 150. 40 times 10 is 400, right? Is that what we have in terms of result? Actually, no. Why not? That's because in matrix algebra, if you take product of two matrices, that actually means something else, okay? Or vectors, it works the same way. So for multiplication and division, you have to keep your eyes open whether you are using this command to generate product of two matrices or matrices based on the concept of matrix algebra, or you are just multiplying two items of two arrays item by item. Okay, if you use this command, that will give you the wrong result if you are trying to get product of item by item, product of these two matrices item by item, just like I did for this blue ink part. Okay, now how this matrix algebra works, that's sort of out of our scope. If you already took matrix algebra class, you would know it. Otherwise, you can just search on Google matrix multiplication. It has a certain procedures it follows, and there is certainly purpose for it. We use that in vectors a lot. But my point is, if you're trying to get products of these two arrays item by item, like 20 times 10, 10 times 20, 30 times 5, 40 times 10, this is not the way to go. Okay, and the same applies for division. So division and multiplication, you have to keep your eyes open to decide whether you want the definitions from matrix algebra or you want a simple item by item operation. Okay, so if you are looking for item by item operation, all you have to do is put a dot before the asterisk sign or slash sign for getting a product or a division results. Okay, so this time if I do B dot multiplication of A, this is what we call using dot operator. Okay, so product using dot operator gave me the result 200, 200, 154, 400, which is my expected result in this case, right? So again, what is item by item product? Just like addition and subtraction, it will pick one item from, let's say, array A, B, and multiply that with an item of array A at the same location. So what is the location of 10 here? It's 1, 1, right? So it will multiply the item at 1, 1 of A. So if I type that in here with my pen, so A 1, 1 will be multiplied with B 1, 1. A 2, 1 will be multiplied with B 2, 1. Okay, so essentially A I J will be multiplied with B I J, right? So I hope you understand the difference of these two. The last operation I want to show you is how to take a transpose. Now let's say you have entered the data of your matrix using rows and columns, but now you need to transform them so that your columns become rows and rows becomes columns. Okay, so for example, I have A. Let's call out A to see what that number is, and let me expand this a little bit so that we can compare the outputs. Okay, now let's type A and put this little um, apostrophe up in there. Okay, if I type that in, what happened is 2010, right, was the row before. So 2010, first row of the array is showing as first column of this array. Second row of this matrix or array is showing as second column of this, right? So rows are converted into columns, and similar way columns are also converted into rows. So the first row of this has converted, sorry, first column of this has become first row of this. Second column of this has become second row of this. Okay, so this is sort of an rearrangement we can use transposing a matrix. Another example would be, let's say if I have, let's say I have a matrix named or array named ARR test equal to 23, 54, 65, 645. Okay, let's take that 45, 47. And I entered them as one row in the array, one single array, right? Now, what if my boss has asked me to perform a calculation where I need them as columns? Let's just open that variable from workspace, ARR test, double click on that to open. If I expand that, you can see I have 23, 54, 645, 45, 47. But my boss doesn't like that, or the program I'm gonna write now is not gonna be very useful if I have them like this. What I want them is to convert this to a column. So I want 23, 54, 645, 45 arranged in this column, but in the same order, right? So what I can do is I can create another variable array underscore test. T, maybe denoting transpose. I'm just giving it another name, or you can just put underscore and T if that is confusing for you. So what I'm doing is ARR underscore test, and what I need to do to transform this, all I have to is put that apostrophe out, okay, and hit enter. All right, now okay, now I have ARRA. Okay, that was spelling mistake, but we'll take that. ARRA underscore test underscore T equal to 23, 54, 645, 54, 47. Now, if you think about it, we had one row, 1, 2, 3, 4, 5 columns. So it was 1 by 5 matrix before, but now we have 1, 2, 3, 4, 5 rows and 1 column. So this is 1 by, sorry, 5 rows and 1 column. So this is 5 by 1 array, and this was 1 by 5 array. And all of these items has been converted into one column, maintaining their sequence, right? So this could be another use of using a transpose of an array. All right. And again, it has a lot of implication in matrix algebra. If you're using matrix algebra, you would know that transposing a matrix is sometimes a little bit hectic if the matrix is relatively bigger. So you can just use this single command using the apostrophe to calculate the transpose of an array, okay, which is really convenient. Now let's look at the last agenda for today. We want to see the difference of character and string type of variable in MATLAB. So far in this class, we have not actually talked about variables containing texts. So let's begin with that. Let's say I have a variable name 1. I put the equal sign. Until this part, storing text and storing number works the same way. You need a variable name, and then you put the equal sign to mean that you are making an assignment. To enter a text, you have to put the double quotation sign up. and type in your text. Okay, maybe I'm entering a name, so I'll use Jake Roberts and put the double quote sign again to close this. I hit enter, so I create a variable with name Jake Roberts, which is cool. All right, now I want to create another variable name2 equal to, I put the single quote or the apostrophe sign and then type another name. Now as you can see, MATLAB took both of them, so it created actually two variables. If I scroll my workspace, you see name1 and name2 using both double quotation and single quotation. But if you look on the left side, the icon for these two variables are actually a little bit different. Okay, let me make my MATLAB window full screen so that you can see this clearly. Let's open these variables actually. Okay, so when I open this, you can see for name2 where I used apostrophe or single quotation, it's saying ch or car, and it's saying the size of this variable is 1/10. And if I go to the variable name1, which contains the text I entered using double quotation sign, that says it's a string and the size is 1/1. So what that means is when I type in something using double quotation sign, although both of them are text, but I'm using double quotation, that saves the variable as a string type, and the size is 1/1. That means that Jake Roberts text, the whole thing is stored as one block. Okay, and if I go to name2, it's actually saving this text between the single quote signs or the apostrophes as individual characters. What that means is it's not saving this Tom Hanson thing as one item. Okay, it's saving T, it's saving O, it's saving M, it's saving the space, it's saving HANSON. Okay, and that's why the size is 1/10 and the data type is character, car for character. So that means it's storing each of these letter as one item of an array. But if you think about this whole thing is one. That's why the dimension of this is 1/1. And for character type, the dimension was actually 1/10. And we can prove that with one more example. So if we go to name1, and if I want to access, let's say, the item at number 5, it's giving me an error because index exceeds number of array elements. So whatever I'm entering or trying to save in these variables, MATLAB is actually trying to convert everything in the form of an array. But the question is what it saves in each block of that array. So what it did when I used double quotation for Jack Roberts for variable name1, it converted this whole thing or saved this whole thing in one single block. So when I said, okay, give me the item at index number 4, it does not have anything at item number index number 5. So when sorry, let me just rephrase that. When I asked MATLAB to return me the character or the letter at location index 5, MATLAB does not have anything there because it saved this whole thing in the first element of the array. Okay, so that's why it said the size of this variable is 1/1. Okay, now let's close that and let's repeat that same command for name2. So when I entered that, it returned me H. So if you think about this, this character type variable name2 as an array of 10 letters or 10 characters and start counting them from beginning 1, 2, 3, 4, 5. So the fifth letter is H. So when I said name2, it actually gave me the letter H. And between these two apostrophes, that means it's a character type item, okay, or variable. So the takeaway from here is, if you save a variable using double quotation sign, MATLAB actually saves that whole thing into a single block in the array. Okay, so this whole thing is saved as one single block, and when you look at the size of that variable, it will show you one by one. If you try to access certain items and use a command like this, you will not get it because the size is one by one again, right? So you'll get an error. However, if you use apostrophes or single quotes, MATLAB will save them as a collection of letters or characters. Okay, and when you try to access an item from this using an index, you can actually do that. So for example, if I use name 6, it will give me character number 6, 1 2 3 4 5 6, so it will give me 8. All right, so what type of declaration you should use for these two, between these two types of variable, depends on your scenario. So if you really need to access or do things with your text at character level, you can go ahead and save them as characters. Okay, if you don't need or don't really need to do things or manipulate things within the text, rather you just want to save them as one single entity and probably pick up the names later on, um, you can just use the string type. Okay, so what I can do now is, as this is the end of the lesson, you can just close off your diary. So as your in-class assignment, I want you to upload the diary file you have in your current directory. That's going to include all your comments. If I open that diary now and clear up my screen, you can see it has all the comments I typed in today on my screen or in the command window, right? So that will be all for this lesson. Thank you all for watching. See you in the next video.